Hi, welcome to this Chassis.ml tutorial video where we're going to build a model using the Scikit-Learn framework and automatically containerize that and push the container image to a Docker Hub account using the Chassis.ml SDK. Okay, let's get started. I'm going to walk through this entire tutorial starting from a blank Jupyter notebook. Now, if you need help setting up your notebook, feel free to visit the examples section within the Chassis repository, where you'll find instructions for getting set up. We also provide a collection of reference examples from some of the most common frameworks out there. And today what we're going to walk through is an example sklearn or Scikit-Learn module. The first thing we'll do is install the required dependencies we'll need to complete a chassis job. Those are the Chassis.ml SDK, Scikit-Learn, MLflow, joblib, and the request library. Once these are successfully installed, we can import the packages we'll use in this notebook and build our model. So today we're just going to build a simple support vector machine classification model, again using modules directly from the Scikit-Learn framework, and train this model on the digits dataset, which is a common benchmark dataset for the computer vision task. So our model will be able to take in an image of a digit, 0 through 9, and tell us what number each image contains. So we'll load in our dataset, do a little bit of pre-processing, define our classifier using the support vector machine submodule within sklearn, split our dataset into training and test subsets, and fit our classifier to our training dataset. So this is training the model right here. And what you'll see is this is one of really only two things we'll need before kicking off a chassis job. Those being, first, we need to have our model loaded into memory. That means that your model could be saved as a local file and you simply load it in this notebook, or you train it and have it loaded in memory from scratch, the way we're doing it here. So once we have our model, we can now define a simple process method. This process method is the sole parameter we'll need to create a chassis model object. Now let's unpack this process method. So this process method requires a single argument, that being input bytes. In other words, we expect this method to accept some data in raw bytes form, where we have to read that data in, regardless of the type of data we're working with. In this case, we'll be working with images and read in those images as NumPy arrays. We'll take that process data, we need to make predictions on it using our classifier that we've defined and trained. And then we have to process the predictions and return them in some sort of format that we prefer. So that's what we're doing here. We load in our data, we make our predictions, and we loop through our results and save them to a structured results list. Pretty simple. And once these steps are complete, we can start interacting with the chassis service. And to do so, we'll start by initializing our chassis client. Now in this case, I've installed and deployed chassis locally on my machine and port forwarded the service to my local host port 5000. If you're running this locally on your machine, make sure that this local URL points to the port that you're running the chassis service on. Or alternatively, if you're using our publicly hosted chassis instance, make sure that this points to the correct URL. Okay, now that we've initialized our chassis client, it's time to build our chassis model. And to do so, we will use this create model method, passing through just a single argument, that being our process method that we defined right here. For testing purposes, we will take the first image in our test set and save it out as a sample JSON file. So in this case, we're just taking the NumPy array, casting it to a list, and saving it as a JSON. And with that sample file path, we can perform two tests. We'll do so separately. And the first test simply tests our chassis model object locally. So in other words, basically all we're doing is taking this sample file path that we just saved out and passing it through our chassis model object, which will execute the process function that we've defined just locally in the environment that we're working in. And as we can see, we get some valid results out. That being the top prediction of this particular image is the digit 8 with a score of 100% confidence. This next test takes a little bit longer to execute, But instead of simply running the chassis model object locally in our environment, we're actually simulating a full chassis job, which will take the chassis model, infer our dependencies based on the packages that we've installed in this environment, create a brand new environment within a Docker container, and run our model code. Okay, and after a few minutes, this test is now complete. We can see the sample model output printed directly to our notebook right here. This is what we were expecting, which is great, which means we can now move on and publish our model, or in other words, kick off a real chassis job that will take our model code, take our chassis model that we've built, and create a container image out of it and push it to some Docker account. So on that note, we need to define some Docker Hub credentials. In this case, I'm using my personal account, where I've defined my account username, and using this fun little utility package called getPass, I'll enter my Docker Hub password right here. And with these credentials now defined, we can execute the chassis job, where we'll use the publish method, pass through a few arguments here, including a name for our model, a version for our model, and my Docker Hub account credentials to kick off this chassis job. And what we see here is this message indicating that our chassis job has started. Now, this job can take several minutes, all depending on the size of the model you're working with. And once our chassis job completes, we can print out our final status variable to see the results of our chassis job. And in this case, we see that it was complete, which is great. Now, let's confirm that our image was in fact built and pushed to the Docker registry we expected. So you can do this in a terminal, or you can do it right in a Jupyter Notebook as well, as long as you add the exclamation mark ahead of the command you're going to use. So because we named our model Scikit-Learn digits version 001, we're expecting the image to exist in my account with the repository name Scikit-Learn digits and the tag 001. And what we see here is the newly created image that we just built using Chassis is now pulled down into my local environment. And so when I use another Docker command to check the images that are available, we see this image that I just pulled down that was pushed to my own Docker registry account with the chassis job. All right, now that we've built this container image using Chassis and confirmed that it worked, it's now time to start interacting with this image. So make sure to tune in to some of our other videos to learn the different ways that you can call this model container, whether that is your preferred serving platform or making local API calls using Postman.